Okay, so last we're going to do a couple application problems. So for this one, we've got a T-joint, skewed T-joint, needs to be prepped. We want to find the angles the bar needs to be cut to place correctly to fit the corner and the length of the inside of the bar. Okay, so the length of the inside of the bar, let's do that first. That should be a little easier. So these dimensions are going to the inside. And I'm going to jot down the decimals: 7/8, 5.875, 5/16. That'll be 4.3125. Okay, so to get that distance, that's the hypotenuse. So that's where I'm going to be adding if I do the Pythagorean theorem. 5.875 squared plus 4.3125 squared, square root of all that. So square root 5.875 squared plus 4.3125 squared, 7.2878. Say 288. Okay, and we'll just we'll leave like that. I guess it depends on if I go to the nearest 16th or 32nd. Looks like it'd be about a little closer to 5/16. If I do 0.288 times 16, I get 4.6. Might want to even go to 30 seconds on that one because we're kind of right in between a quarter and 5/16. Now for the angles, so let's do, I'm going to do this bottom one. I'm going to put an A down there first. So I'm going to go off of the dimensions I'm given. So opposite and adjacent. So I'm definitely going to use tangent here if I'm going off of the horizontal and the vertical. So tangent of the angle 4.3125 over 5.875. So I'm doing the smaller angle right now, the one across from the smaller side. So it should be a little less than 45 degrees. So when I do tangent inverse, second tangent on this one, so I'm looking for the angle. So second tangent, 4.3125 divided by 5.875 is 36 point, definitely for this, the nearest tenth would be plenty accurate enough. So 36.3 degrees. Then the other angle, it's not really labeled, so I'm just going to jot down 90 minus 36.3 is 53.7. Okay. Now the next one, we have a bolt hole circle that has 8 holes evenly spaced. So evenly spaced around this circle. There's 8 holes. Find the radius is 5 3/4. Find the distance between the holes. So when we say the distance between the holes, you know, I didn't really specify it, but usually we're talking about from the center of one hole to the center of the next hole, and we're talking about a straight distance. So if you're thinking like, oh, this is just like arc length, it's going to be a little less though because it's straight across. And usually when we are inputting something like this into a machine, we want that straight across distance, not the arc. That could be helpful for laying something out maybe sometimes, but usually when we're inputting it into the machine, we want to know the distance between consecutive holes to go around. Okay, so I'm gonna use some trig here. So I'm gonna draw a triangle in one of these sections. So first of all, I'm only given one number on the triangle, the 5 3/4 radius, but I can figure out based on the fact that there's 8 holes, do 360 divided by 8, which is, it should be 45 degrees. Because if we kind of look at this one turns out nicely, 90 degrees, cut that in half. So 45 degrees is down here. Now I don't have a 90 degree. So here's a situation where I'm going to have to draw a line to make a 90 degree angle. Okay, so that means what I'm going to do is I'm going to cut straight down the middle to make a 90 degree angle right here. Let me draw this a little bigger. So it's like here are my consecutive holes. That's what I'm trying to find, that distance across. I'm going to put the 45 down below because now when I cut this in half to make a 90 degree, now this is 22.5. And then my radius is the hypotenuse. Okay, so I'm looking for this, I'll put a little X up here. I'm looking for that distance between the holes, so if I'm using 22.5, that side is opposite, and I know my hypotenuse, so I can use sine. Sine 22.5 is x over 5.75. Okay, so this is situation 1, multiply 5.75 times sine 22.5. So unknown on top, take the side I know times the trig part, sine 22.5. So I'm getting 2.2004. Now we had cut that triangle in half, so a lot of times when we do that, when we cut something in half, we might have to then double it to get back to what I want. So times 2 is going to be 4.4008, actually like 86. Now I'm keeping a lot of decimals here because something like this, we might want to be pretty accurate. Because if you are off and you go between these two holes and then you do that again and then you do it again and you do it again, by the end, you know, if you're not very accurate, doing that 8 times around, you're going to create a pretty big error there and you might have too far of a gap in between. So if this is something you're inputting into like you know, like a water jet or something where it's being punched out, maybe you could even go to 4 decimal places out. So you could go 0.4009. It all depends, but we'll just leave it at that. It all depends on how you're setting this up. Okay, so now last one. This one specifically more so for those in CNC machining. So this again, it's like it's a bolt hole circle, but we're setting this up more like on something where I have coordinates, x, y coordinates. So x is the horizontal, y is the vertical, like we've done a little bit with before. But there's 10 circles. So let's use that 360 divided by 10 right away so that I know between each hole is 36 degrees. Okay, now this one, I'm going to set this up a little differently because it's more like I want to know the coordinates. We're going to be doing a lot of the same calculations as the last one, but I want to know what's this coordinate of A. So what is my x that I go over and then my y that I go straight up. Okay, so I'm going to actually, how I kind of started just drawing this out, I'm going to draw a triangle right there. So I'm going to redraw this over to the side. So this is to try to find angle A. The other thing I know is that 12 is my radius. So there's my 12. Now here, between A and the angle below it, if we kind of look at how this is symmetrical, it looks like that's going to be half of 36 degrees. So this is going to be 18 degrees because the one below it is evenly spaced, symmetric. So I can just take 36 divided by 2. Okay, so, and I'm going to label this as my x for my horizontal and my y is my vertical. So to find, well, let's do x first. Adjacent, and I know my hypotenuse. So cosine 18 is x over 12, adjacent over hypotenuse. So 12 times cosine 18. That'll get me x. 12 cosine 18. 11.41. It says to go to the hundredth. Okay, and this is centimeters, so we'll just leave it as a decimal for sure. Okay, now for y, I'm going to set up sine 18, because now I'm doing the opposite in hypotenuse, is y over 12. So now I'm doing 12 sine 18. Now, if you're pretty good with your calculator, you could save yourself some typing. Just arrow up, grab that 12 cosine 18, replace cosine with sine. Notice how it's the same, just the different trig function, 3.71. Now, I want to point out, I could have done the Pythagorean theorem at that point as well, but it wasn't that much harder to set up the trig, because it was very similar for each of them. But if I want to do a check, I could do square root of 11.41 squared and 3.71 squared. Make sure that comes out to 12. Should be pretty close to 12. Okay, so now my coordinates, that means I'm going to go over 11.41 centimeters and up 3.71 centimeters. And that sounds reasonable. That it'd be over 11.41 and then up 3.71. Okay, now let's find B. Now, I could do this a couple different ways. I could cut straight to the right, and then that would be 36 right there, or I could cut straight down. Now, sometimes just to be consistent and to have, if you're going to end up doing this a decent amount in your program classes, always go to the x-axis and the calculations are going to be similar. So we'll kind of compare with going straight down to the x-axis, and I want to figure out this b right here. Now I have to do a little more figuring out with my angle, because between these two, this would be 36, and just like we had gotten 18 over by a, that's going to be 18. So 36 and 18, 54 right here. Otherwise, I could have done 90 minus 36, because if I know it's 36 between b and that y-axis, it's going to be 90 minus 36 to get below there. Then again, 12. And again, I'm going to label x and y. So notice how if I want to find x first, that's going to be cosine, adjacent, and hypotenuse. Cosine 54 is adjacent over hypotenuse, x over 12. X over 12. So 12 times cosine 54. Notice how this compares to above. If you always go to the x-axis, to find your x value, it's always going to be whatever the radius is, cosine of the angle. The angle, though, needs to be with the x-axis. So 7.05. And then for y, sine 54, because y is opposite of 54 degrees. Sine 54 is y over 12. 12 sine 54 is 9.71. Now the one thing we just have to watch, if we're going to the left on x, this is actually going negative, just like if I went down for y, it would be negative. So my coordinate for b is a negative 7.05, because I'm going to the left of 0 from the origin, from my start, and then I'm still going up, so the 9.71 is positive. It'd only be negative, negative, down, and the bottom will left.